Hello everybody, welcome to my class. Today we are going to discuss about continuous probability distribution, and this is the chapter 3 from Nelson Mathematics book compiled by J. Crawshaw, J. Chamber and P. Balaam, and this is especially designed for A-level mathematics and statistics courses. So here in this chapter we'll discuss about what is the what is called continuous probability distribution and how we deal with the problem related to such distribution. So in this class I'll try to cover almost all idea about this probability distribution so that your CIE exam questions will be covered. So then let's start now. Before we discuss more about continuous probability distribution, we shall first talk about discrete random variables again. A discrete random variable is a variable which can only take a countable number of values. The variable is said to be random if the total sum of the probabilities is 1. So that means here, if you would like to say x as a random variable, the total probability, all the points of x must be equals to 1, then it will be called the discrete random variable, and the probability associated with that sort of random variable will be called the discrete probability distribution. Here you can see like it is a variable that can take individual values each with a given probability. So let's consider the probability distribution of x. The score on a fair cubical die is as follows. So this is the probability distribution. So for example, if you have any dice, cubical dice, then you can see that on the cubical dice there are 6 faces, each marked as 1, 2, 3 up to 6. And suppose the dice is fair. So if the dice is fair, you have the numbers like this: 1, 2, 3, 4, 5, 6, and each face will have equal chance of turn up because we have taken the dice as unbiased. So here in this case, if you talk, the probability of 1 out of 6 will be 1 by 6, and probability of 4, so how many 4 here? Only 1 4 out of 6, so probability is 1 by 6. 1, 2, each of 1, 2, 3, 4, 5, 6 has probability 1 by 6 in this case. So we have no other options in probability area other than 1 by 6. So we can consider 1 by 6 as the probability function for this discrete probability distribution. If you say this is the probability function in general, for example, in general, if you would like to write, then it is going to be px equals to x equals to 1 by 6. This sort of thing will be called the probability mass function of the discrete probability distribution, or for the discrete random variable. So you can see here the probability mass function. This is also called probability function of discrete random variable x, and it depends on the probability measure of the underlying sample space 1, 2, 3, 4, 5, 6. So this is a kind of function. You can say that this is a kind of constant function, and constant function is also a function. So here we are dealing with the probability function. This is also the probability mass function for this kind of discrete probability distribution, and it can be in the form of variable also. For example, px equals to x equal to kx. So if x is a discrete random variable, then we can say that this is the probability mass function for that discrete probability distribution, or for that discrete random variable, provided the total probability is 1. So why total probability is 1? If the total probability cannot be 1, in that case we cannot say that x is the random variable. You can have a look. We shall now talk about continuous random variables. This is a random variable where the data can take infinitely many values: 5 to 10, 10 to 15, 15 to 20, etc. That is, a continuous random variable cannot take precise values but can be defined only within a a specified interval. For example, if I'm talking of 5 to 10, there are four values, frequency is 4, and for x interval as 5 to 10, I'm talking only that at this time. So what will that 4 value? It can be like 4.1, 5.1, 5.2, 5.3, maybe 5.9 also, or other possibilities can be 9.2. So these are the four values. So we can consider any of these values in between 5 and 10. So we are not sure that which values are there, only the boundary points are known. And therefore we can say that it cannot take precise values but can be defined only within a specified interval. Okay. Uh, Here are some examples. So, for example, you can say like a random variable measuring the time taken for something to be done is 5 minutes. Measured to the nearest minute could be anywhere in the interval 4.95 and 5.05 or 4.5 and 5.5. What does it mean actually? It means that, for example, you can say that it takes 5 minutes to reach up to 2 kilometer distance by bike from this point. It is not possible that you will reach to that destination in exactly in 5 minutes. It's not possible, in fact, in practice actually. So what happens, if it takes 5 minutes, it can be a bit more or less with some error. So error doesn't mean that there should be big difference. There will be a small difference in the expected time here. If you say it takes 5 minutes, then you are talking of some interval of time, more or less. More or less means if there is very small error of, for example, you can say that the error of 0.05 minute, because we are talking of minute, 0.05 minute. In that case, what you can do, like more or less means less than that means you deduct this 0.05 from this number, then we have this value, then you add the same number to the 5, that will be more, and then we'll have another value. So roughly our time will be between 4.95 to 5.05. For example, if you are taking up to two significant figure or to only one decimal place, if there is a little bit big error in the time, for example, so in that case you can take out the difference as 0.5 only. So this is the general tradition in mathematics and statistics, that we take very small difference between the intervals. If you are talking of a time 5 minutes or 10 minutes, something like this. So here again we can deduct this 0.5 from 5, then we have 4.5, and if we have the same value we have 5.5. So more or less a difference of 0.5 minute if you say, then our interval will be like this. So this is not necessary, not compulsory to stop to only one number. It can be like difference can be like 0.1, more or less 0.01 second. It is also possible that you write 0.00 1 second. It is also possible that you take a difference of more or less if you are talking. So what level of accuracy you want to reach, it depends on that, 0.005 and etc. So if you are talking of less than that, little less than that, then you deduct this number from the given time or given number. And if you take a bit more, then you add the same number, and then we'll have interval form like this. And same thing happens here. So this type of variable is associated with measurement of characteristics such as time, mass, or length. Now we shall talk about probability density function. So just like the probability function for the discrete probability distribution, we say this is probability mass function. So here, if x is continuous random variable, so the probability function for this continuous random variable or the continuous probability distribution, so that probability function is called the probability density function. So here you can see it says that the probability function of continuous probability distribution is called probability density function. Distribution of probabilities based on continuous random variable, for example, say x, is called continuous probability distribution. So here x is defined by its probability density function fx, and it can be illustrated by the graph of y equal to fx, provided that total probability is 1. So here in this case, you can see that the probability in continuous case, random variable case, are expressed in terms of a continuous function, and the total probability in case of discrete random variable, we used to add this distinctly, like p1 plus p2 plus dot 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 up to pn, for example, and that used to be 1 here. So we, in the discrete case, we add them individually here at different point, and hence we find the total probability as 1 in order to say x as the random variable. But here in this case, instead of adding them directly, because this is the case of continuous, so we integrate the given function under the given range of value of x. So x belongs to R, means this is the real number case, and x can have some defined range of values. Let's now discuss some examples that demonstrate what is the probability density function, or what is the probability function for continuous random variable. So here in this case, let's suppose that a function is like this. This is a continuous function. So ft equals to 3 by t4 for t is greater or equals to 1 and 0 otherwise. What does it mean? That ft itself is the probability in the form of function, and it is defined as 3 by t4. And it says that 3 by t4 is only for t is greater or equals to 1. That means is for the value of t greater or equals to 1 only. And 0 otherwise means what actually? So actually, if you talk about this curve mathematically, it will go like this, and go near and near to the y-axis, and but never touches. That means it shows asymptotic nature about the y-axis mathematically. But statistically, it is defined in some given range of the weighted value along x-axis here. So that means 3 by t4 is defined for t is greater or equals to 1 only. For the rest of the thing, there is no probability defined. That means probability is 0. That's why it is written as this is 0 otherwise. Now we are talking about the total probability. Total probability means we add up all the probabilities 1 and beyond. So how do we add this in a continuous form, in the functional form? We always integrate the area under this curve. So if you find this area between 1 and infinity, then it will give you the total probability. So by using the law of, or by using the idea of integration, so you can, instead of writing sum, you can write sign of integration, and then it starts from 1 and will go to infinity, and your given function in this case is 3 by t to the power 4 and then dx, and in fact this is 1 to infinity ft dt. So here it is t, so we write here t, so this is dt. Now let's integrate this function. So t will be taken out, and this is 1 to infinity, and then it is t to the power negative 4 if you use the reciprocal thing here, and this is dt. Next step will be just integrate it. So it is t to the power minus 4 plus 1 divided by minus 4 plus 1, and then in the range 1 to infinity. Let me take this here. So we are going to find infinity to the power minus 3. It means you can write 1 by infinity to the power 3, and any power infinity will again be infinity, and finally this is going to be 0. So here in this case, it's going to be, this value is going to be 0, and this is 1 in fact. So this is 1. So any power to the value 1 is 1 itself. You can see that in front, when you cancel it, we are left with this negative sign. So it will be here. This is negative sign, and this is negative sign is here. So negative 1, negative sign plus another negative sign will make it positive, and finally the total probability is 1 in this case. So as the total probability we have found this as 1, therefore t is called the random variable, and in this case this is the continuous random variable. So we can say this variable as random provided the total probability is 1. We have another example here, and in this example it says that the continuous random variable x has probability density function given by fx equal to this k. It is defined between a to 10. 0 otherwise means it is not defined beyond this interval value of x. So here k is a constant. It is known that probability of 5 less than x less than 8 is equals to 0.5. So this part is also given. So based on all the information, you have to find the value of k and a. If you draw a graph of this function, so your function is fx equals to k. So it is a constant function. It is a constant function, just like here we have seen this is 1 by 6, px equal to x equal to 1 by 6. So if you draw the graph of this kind of function, your graph will look like this. There will be some positive value of k. Here on the y-axis, k cannot be negative because probability cannot be negative, and this is 0 for example. And say this is 1 because the value of probability cannot exceed 1. Okay, then if this is a constant function, so this value is k somewhere in between 0 and 1, and your graph will pass through point k on the y-axis parallel to the x-axis. Alright, so this is the mathematical graph for this function. But what it is statistically? Statistically, if you say that fx equal to k, statistically we can say that fx equal to k between a to 10 only. So if you are talking something beyond that, this fx doesn't exist there. Therefore, we call that fx equal to 0, otherwise. So this is, if this is 1, for example, if this is 1 and then this is 2, up to, we talk up to 10 is here. A can be somewhere in between, A can be here also, for example, this is A. So this sort of function is defined statistically between x values a to 10. So this is valid for start from A and ends to that. So statistically this is defined in this rectangle only, but mathematically it is defined for all x values. You can see. Now it says that where k is a constant, now it is known that probability of 5 less than x less than 8 is 0.5. Then we have to search somewhere 5 and 8 here in our graph. So dot dot and say here is 8 for example, sorry 5 for example here, and then another 5 6 7 8 for example here, and then it is telling you that between 5 and 8, although the figure is not to the scale, but you can understand it, although between 5 and 10 the area is given as 0.5, that is 50%. So if it is a continuous function, then how do you find this area? You have to integrate the given function for the value of x between 5 and 8. So here you can see, like here it is given that p5 less than x less than 8 equals to 0.5, and then it means you integrate the given function from 5 to 8, and your fx value is k in fact here. So fx value is k, and then dx, and it is given as 0.5. We can also write 1 by 2. What we have done actually, we have actually integrated the given function from 5 to 8 fx dx, and from 5 to 8 it is given that this is the 50% value in fact in this total area. And now let's integrate it now further. So it's going to be k is constant, so you can take this out. So it is 5 to 8, and then dx, this is dx means 1 dx equals to half. Then it is k integration of 1 is x, if the variable is x, it is 5 to 8 equals to 1 by 2, and then you have k. So here you require the knowledge of integration, actually the definite integral. So here it is 8 minus 5, and this is going to be half, and then it is k times of 8 minus 5 is 3 equals to 1 by 2, and then finally you have k equals to 1 by 2, as it is multiplied here. If you transpose to the right, it will go to divide. So here times it is 3, so it is divided here, and therefore your value of k we have 1 by 6. Now we have already obtained the value of k. Now it is saying that we also find the value of a. So value of a, your given function is defined for the value of x between a and 10. So if x is the random variable, the total probability must be equals to 1 in order to say x as random variable. And the total probability has been defined in the range of value of a from value of x from a to 10, and you can write fx dx equals to 1. That means we are talking of the of this entire area now, and that covers the whole 100% of the area. So here now we have a2 and then minus a equals to 6, 10. If you transpose to the left, it is minus 6, and then if it goes to the right, then it will be plus a, positive a. So therefore your value of a in this case is 4. Therefore the value of a you obtained is 4, and the value of k you calculated as 1 by 6, and these are the okay. We shall now discuss about mean, that is also called the expectation and variance of continuous probability distribution. So here in this case, let's suppose that x as the continuous random variable, then we have to see that how we find Ex and also Vx, that is variance of the distribution. So for discrete probability distribution, you have seen that expectation of x equals to summation of x and px, provided that summation of px is 1. That is, the total probability is 1. So in order to say x as the random variable, there must be total probability 1. So if summation of px is 1, in that case x is random variable, that is discrete random variable in this case. But what happened when it is continuous distribution case? So in continuous distribution case, summation sign will change into sign of integration. So here we in the discrete case, we sum this term one by one individually and distinctly, but here your when you draw a graph for any continuous function, your graph will be something like this, and then you have to integrate this graph under some given limit of x, for example a and b. So therefore in continuous case, instead of adding them individually, you have to integrate the area that has been covered by this function. So we replace summation by sign of integration if we are dealing with the continuous random variable, and then we have x over here, and in place of px we have to write fx dx. So here px is the probability function or probability mass function when we consider x as a discrete random variable, but here this fx will be the probability density function. So when there is probability function mentioned for continuous distribution, and in that case we call that probability function as probability density function. In the integration, you have to integrate the given term for given range of value of x. So x belongs to R means here R is the real number. That means it can be like from lower limit a to upper limit b. So in general, we can write x belongs to R. Similar thing you can do here, like instead of writing sign of summation, we can use sign of integration. X belongs to R, and x times fx dx, provided that total probability x belongs to R for the integration. So total probability fx dx equals to 1. So this is total probability. And now we have to understand that mean is denoted by mu, and also this is expectation of x, and expectation of x formula has now become like this. So this is the formula for expectation of x. Now let's talk about this variance sigma square. So in order to talk about the variance, so you know that from the discrete case, that variance of x is expectation of x square minus mu square, and then expectation of x square if you write in the probability and in the summation form, and then it will be summation of x square p x, and then mu square remains as it is. So mu square we can find by using the same formula here, mu equal to summation of x px if this is discrete random variable. If x is the continuous random variable, we can find mu by using sign of integration. So here in this case, as we have learned for the discrete probability distribution, now we are learning the continuous probability distribution. Therefore, what happens if you suppose x as continuous random variable, then this summation will become sine of integration, then x square, and this px will become fx dx, and then it remains mu square. Now in this case, this is for the continuous probability distribution, and you can write x belongs to r. You have to say that the range of values of x in the integration. So in general, the lower limit can be m and upper limit can be n. M and n are any numbers. So here in this case, what you can write actually, expectation of x square minus mu square. Can also write in place of mu square. For example, it is mu square, then mu itself is expectation of x, so it will be expectation of x square. Therefore, you can also write variance of x as expectation of x square minus expectation of x whole square. All right. So in this case, I am dealing with now variance of x in general is expectation of x square minus mu square. And in expectation of x square, you can write sine of integration, and then x belongs to the real number, and then it is x squared. We write here x squared. Then for px, we can write here fx dx, and then minus mu squared. Here the mu squared is for continuous random variable. So in this way, our formula for the variance as well as for expectation of x in case of continuous probability distribution have been ready now. So you have to now remember these two formulas. If you are going to find expectation of x, you have to use this formula, and when you are going to find variance, then you have to use this formula. Here are some examples you can see. This example says that the continuous random variable t has PDF given by ft equal to this. So you can see that this is in the form of some reciprocal function with a constant contained with this function and 0 otherwise. So first of all, let's draw the graph of this function in order to understand what is it, what it is mathematically and what it is statistically. So if I draw the graph, for example, and then it is 0, and then it is 1, 2, and it will go on and on up to positive infinity, and here 1, 2, it will go on and on up to positive infinity. Here to the left side it will be negative infinity, to the downside it will again be negative infinity for the y-axis, and here this is x-axis. So what I consider my function is here k by t square, that is y equal to k by t to the power 4. So in this case, if I keep on plugging in value of t, it starts from 1, and if you keep on going on and on, so as you increase the value of t over here, so this is k equal to t to the power 4, then what happens, as you increase this value, the whole thing will keep on decreasing. So as value of t increases, it goes, the curve will go near and near to the x-axis. That means it is showing the asymptotic nature of curve about x-axis. Now when you keep on decreasing the value of x from, for example, x equal to 2, and if you go towards left this way, then as you decrease the value of t, then value of y will keep on increasing and increasing, and then it will go near and near to the y-axis, but it never touches that y-axis. So at this part, it will show the asymptotic nature about the y-axis. Now what happens when you put the negative value for t? So even if you put negative values for t, and t is along the x-axis, your whole value will remain positive because of this even power of the variable t. So if I am going this way and I am writing that it is negative 1, negative 2, and I will go to the lowest and lowest value in the negative sense, then what happens, as you decrease the value of t in the negative sense, then it will go near and near to the x-axis, but it never touches the x-axis. And the similar work, if from left to right, if you go here, it will go near and near to the y-axis, but it will never touch the y-axis. That means from left side also it will show the asymptotic nature mathematically about y-axis and also about x-axis. All right. And now, so this is the mathematical pattern of the graph for y equals to k to the power k divided by t to the power 4. Now, how it is statistically? If you can see here, this is ft equals to k divided by t to the power 4, and this is defined for t is greater or equal to 1 only. That means statistically, if you talk about the curve, so that curve is of only this part, not the any part left of this number 1 on the x-axis. So it said that k by t square for t is bigger or equal to 1. For rest of the thing, for example, for less than t, if you say, there is mathematically the part of curve here and here also, but that will not be considered. That means probability doesn't exist, or the probability hasn't been defined for other range of value for t. So therefore, mathematically the whole part is the curve, but statistically we can consider the curve from x equals to 1 to x equals to infinity. All right. So I hope you understood the difference between mathematical meaning and the statistical meaning of the graph. Now next, it says that so that k equals to 3. That means how can you show that k equal to 3 means, you know that as statistically the curve defines from actually x equals to 1, then total probability, if you find the area under the curve from 1 x equal to 1 to infinity, that will give you the total area, and that total area under curve will be the total probability for this distribution. And as t is the random variable, therefore the total area under this curve, that is the total probability, will be always 1. So we'll use that sort of properties of probability in order to find the value of k. So here you can see that we know that total probability is 1, and total probability is given as, that is, x belongs to r fx dx equals to 1. In discrete case, just like you should write summation of px equals to 1, here we write integration sign in place of summation, and in place of px we write fx dx. And if you integrate the given curve in the entirely defined area as per it is given, and then that will give you the total probability. After that, you can see that fx, so here in this case, in place of x it has been used t over here, so you replace x by t. That means first of all the range of value of t is 1 to infinity, and fx, that is here it is ft, so ft is k divided by t to the power 4, and so we write k divided by t to the power 4, and in place of dx we write dt equals to 1 in order to find the value of k. Now after this step, just integrate this. So note that you will require sound knowledge of integration, all right, before you deal with the problem with continuous probability distribution. This is most important to understand that how to integrate different kind of functions. So after this step, I can see here that k is constant, so you can take k outside, and then this is 1 to infinity, and if you break this reciprocal, then you can write 2 to the power 4, and then this is dt equal to 1, so it is k by minus 3, 1 by infinity is 0, and this is minus 1 equals to 1. Now this negative sign and another negative sign, when they multiplied, that will be positive. That means we are left with k divided by 3 equal to 1, and therefore it is k equal to 3, and it says that to show that k equal to 3, hence true. Now in the same question, you can see that the question is asking you to find expectation of t, that is mean of this distribution, that is you have to find mu or expectation or mean of this function. So here in this case, in order to find the expectation of that function or that distribution, so you can see in question number 2 here, you have to find expectation of t. So here expectation of t equals to x belongs to r or here as t is the random variable in place of x, so you can write here t belongs to r. Then in place of x you can write t, and then in place of fx you can write ft and then dt. And after that you have in this graph you can see that t starts from 1 greater equal to 1 means this t is from 1 to infinity. So in the range we can write this is 1 to infinity and t is here, and ft is k by t4, so we can write ft as k by t4 t to the power 4, and then this is dt. So now it is negative 3 by 2, and then you can write that again in the reciprocal form, so it is t square, and then it is 1 to infinity. Now just take these limits in this variable in this result, so it is negative 3 by 2, and then you can write 1 by infinity square, then minus 1 by 1 square, because one time you have to put the upper limit for this variable and another time you have to put lower limit, and in between them there is negative sign. Now we are left with minus 3 by 2 and 1 by infinity. So this infinity square. So 1 is infinity square is still infinity. So 1 by infinity is 0. And then this is minus 1. So our expected value is this negative times negative is positive. So it is 3 by 2 times 1 is 3 by 2. So expectation of this continuous probability distribution is 3 by 2, or you can also say that expectation of the continuous random variable in this case is 3 by 2. After that, the question talks about also to find variance of that distribution. So variance Vt means this is the third part of this example, and variance you can see that you know that variance of x equals to expectation of x square minus mu square. So this is our mu. Alright, so mu already calculated, so we should now try to calculate this. But here in this case, the random variable is given as t, so we write Vt equals to e x t square. You can use capital letter also, it doesn't matter here, or a small letter, and this is mu square. And you know that if this is t square, then it is t belongs to r. That means we will integrate this function in the range of value of t in this case instead of x, because variable is given in terms of t. And so it is t square then ft dt minus mu square means you can put the same value, so this is 3 by 2 square. So let's proceed further. So here first of all we'll try to find this value, and then finally we substitute back in order to calculate the variance of t. So this function is t belongs to r, t square ft dt. So we shall work with this only for some time, and then we substitute back that what we have got from here. So here it is range of value of t in this case. We have seen it just now that it is t is greater equal to 1. That means it is from 1 to infinity, and this is t square, and ft is k by t4, and we know that value of k is 3 now, so it is 3 divided by t to the power 4, and then this is dt equal to, just simplify it first, and then it is minus 3 times, and 1 by infinity is 0, and 1 divided by 1 is 1, so negative time negative is positive, so your answer is 3. No, not the answer is 3, that expectation of t square is 3 in this case. So therefore your variance value, that is therefore Vt, so Vt is going to be equals to, for this we can replace, we have just now calculated this Et square, and then it is 3, and then it is already here 3 by 2 square. Now let's calculate it. So it is 3 minus 3 3 are 9 and 2 2 are 4. It is 12 minus 9 divided by 4, and then this is 3 by 4. So this is the variance of this continuous probability distribution function. Okay, we shall now talk about cumulative probability distribution function, and this is denoted by capital Fx. And also this is called the distribution function. So distribution function, unless otherwise stated, this is the cumulative probability distribution function. Cumulative probability distribution function is just like you add up the probability one by one up to the given extent, but not as a whole at that time. Maybe may or may not be the whole probability. So cumulative means you keep on adding probability within the given range of values for the defined range of values of x. You can see here fx equal to p, x is less or equal to x. So for example, in this figure, your density function is defined for x between 0 and 4, including maybe inclusive. In that case, for example, if you like to add up the probability from say it is 1, so if you are within this 0 to 4, if you are adding a probability from 0 to 1 only, and then you develop a kind of general function, then that will be called the probability cumulative probability distribution function. It is also possible that not from 0 to 1 only, maybe 0 to 2 we can integrate the function, and then that means we have been adding the area from 0 to 2. And then in general you can say this is on the x-axis it is x for example, or t for example. So if you integrate the area of the given curve under the range of value of x from 0 to x, and then you'll have new function develop, and that sort of function is called the cumulative probability density function. So maximum value of cumulative probability distribution function will be 1, that is the total probability, and all the sort of work we do within the probability 1. This is like cumulative frequency as in frequency distribution table. And here is one example given here that x is a continuous random variable with PDF as shown here. So probability density function is fx equal to 1 by 8 times of x, and this graph is for the function fx equal to 1 by 8 times of x. And now find the cumulative distribution function at this case y equal to fx. So first of all, from this probability density function, we have to find the cumulative distribution function, and then we have to sketch the curve, and then we have to see the difference between those two curves here. So here ft means in general t, I am taking any value t between 0 and 4 in this case. For example, t ft equal to, you can write 1 by 8 x dx. It's okay. Ft, that means we integrate the given function 1 by 8 in the range of value of x, or in the range of value of t from 0 to t here, just like saying 0 to 1 and 0 to 2. So in general we can say this is 0 to t. After integration, so 8 is constant, it is taken outside, and then integration of x is x squared by 2, and from 0 to t, and after putting back this range of value of for t here in this function, so you can write this is t squared by 18. So this is the new function now. So as we are, our function is given in terms of x, so we replace t by x, and then the situation will be like this. Then capital Fx is 0 for less or equals to 0. Why it is? Because less or equal to 0, if you are talking, although mathematically this curve has the part below the 0, but statistically it says that this function is defined between 0 to 4 only. So any probability below 0 will be 0. That means we are integrating 0. Between 0 and x in general, between 0 and 4 in general, it is x squared by 16 that we have taken from here. What about bigger than that? So at this point, it attains the highest probability. So if you integrate from 0 to 4 itself, the total area has been covered. So total height will be here up to fx. If you talk about, this is 1. And after that, even if you consider the value greater than 4, in that case, although the curve has path like this, but the total probability cannot exceed 1 because of the definition of the probability. Therefore, instead of considering this part of the curve, all the values after x greater or equal to 4 will be equal to 1, and this is the reason why there is a straight line after this. This is the way that how we obtain cumulative distribution function from the given probability density function. So this part is most important to understand. We shall now discuss how to find median and quartiles in continuous probability distribution case. So here our topic is now median and quartiles when x is continuous random variable. So you know that median takes the 50% of the value. So therefore, if you integrate the given probability density function from lower limit to m, that is the middle point, then that will cover the area of 50%, that is 0.5. So when you integrate the function from a to m, you can say this is median point, then fx dx equal to, if you equate that equal to 0.5, then the value of m you obtain by this method will be the median value for that function. Similarly, the first quartile takes 25% of the value, or also you can write that is equal to 1 by 4, and third quartile will take 75% of the value. You can also write it will be equal to 3 by 4th of the whole data. So the method of finding medians and quartiles are not different, only the difference in writing here. For the median we write here 0.5, for the first quartile it is 0.25, and for the third quartile it is 0.75. And just now we have learned about the cumulative distribution function, so that will be helpful in finding median and quartiles. Now here is one example. The example states that the continuous random variable x has probability density function given by fx equals to 1 by 8x. We have taken the same function from 0 to 4 and 0 otherwise. That means it is not defined for other range of values of x other than 0 to 4. And then in question number 1 we have to find the median of x, and in the second you have to find the interquartile range. So how do you find the median of that? So you can do in two ways. So just now you have learned about fx. For this function was x squared by 16, x squared by 16, and then if you say fx as fm equals to, then it is m squared by 16. That means here m is the median, and you know that median takes 50% of the value. That means in decimal, or it is 0.5 equals to m squared by 16, and then you solve it. It is m squared by m squared equals to 0.5 times 16. Okay, when you transpose this to the left, and then half of 16 is going to be 8, and now therefore m is equals to, take the calculator, then m will be equals to plus minus under root of 8. So plus minus under root of 8. So first of all we find the square root of 8. So the square root of 8 is, this is plus minus 2 root 2. So our median value is both positive and negative times 2 root 2. But what happens here, if you have look at this curve for x by 8, that is for x by 8, you can see that media all the values are positive. That means also the range of values for x is less or equal to 4 and greater equals to 0. That means median must lie between 0 to 4 only. So median cannot be negative in this case. So that is your median value is positive 2 root 2, and this is the answer. So in this way you can calculate the value of median by using the cumulative distribution function, cumulative probability distribution function. You can do this directly also. So directly, how can you do this? Actually, in alternative way, you can just try to write that integration from the lower limit is given as 0, and then it will go to highest value is 4, but we don't need highest value, we need the value in the middle of 0 and 4. So we write here m, and then this is fx dx is 50% or 0.5 or 1 by 2 as you need to write or as you like. And now it is 0 to m, and your fx value is x by 8. So it is 1 by 8 times of x dx equals to 1 by 2 to positive 2 root 2 is the median value. So in this way you can also find the median of the distribution. And similarly, you can find the interquartile range. So in order to find the interquartile range, you should have values of Q1 and Q3 both. So let's find Q3 first of all, or you can find Q1 first of all, it doesn't matter. So your fx value was, you can see your fx value was here x squared by 16. So it is x squared by 16, and if you are going to find the first quartile, then you write here Q1, and then it is Q1. If you write here Q1, then it is going to be Q1 squared by 16, and Q1 takes 25% of the value, so you can write 1 by 4, and then this is Q1 squared by 16, so it is Q1 squared is equals to 1 by 4. If you transpose towards 1 by 4, then it's going to be 16. So 4 ones are and 4 fours are, it is 4. So therefore your first quartile value is plus minus 2, but you take only the positive value because x is between positive 4, 0 and positive 4. So negative value of Q1 is not valid here. Q1 can't be negative in this case. So therefore Q1 value is 2. So we have got the value for Q1, and now we shall calculate the value of Q3. So in order to find the Q3, you can just put here Q3, and to the right side instead of 1 by 4 you can put 3 by 4, or if you like you can just integrate the given function from the lower limit at 0 to Q3, and then fx value was 1 by 8x dx, and it is 75%. That means it is 0.75, or this is 3 by 4. You can do in either way. Should be between 0 and 4. So there is no negative values between 0 and 4. So therefore your Q3 value is 2 root 3. So therefore your interquartile range, you know that the interquartile range is Q3 minus Q1. Then write down the Q3 value is 2 root 3, and this is 2, so this is minus 2. And if you would like to have the exact answer, you can just leave it as answer, that will work, or you can simplify like this. 2, if you take out common, then root 3 minus 1, so you can express your answer like this also, if you would like to express your answer in exact form. If you write the answer in the significant figure, then you can do this also, then 2 root 3, and then it is minus 2, or you can calculate from here also, and that is equals to, let me write, it is SD. If I write, then it's 1.46 for 3 significant figure. So you can express your answer in exact form and also in a significant figure form as you like, or as it is advised in your question. Okay, guys, we have a few more examples. The example states that the continuous random variable x has probability density function given by fx equal to k times e to the power 2x for 0 to for x 0 to 4 and 0 otherwise, where k is a constant. So that k equals to 2 by e to the power 8 minus 1, and also you have to find the mean of x, that is mean of this continuous random variable. In order to show that k equal to this, so we know that the total probability, so in question number 1, if you are talking of question number 1, then you know that total probability must be equal to 1, since x is continuous random variable, and this total probability will be given by the total area under the curve fx, so that is x belongs to R, fx dx equals to 1. That means here fx is k times of e to the power 2x, and then integration from 0 to 4 dx equals to 1. and then it is constant, so we keep it outside, and then integration of e to the power 2x is e to the power 2x over 2, and this is equals to 1, since you know that the integration of, and finally we have k equals to, if you transpose this towards right side, so 2 is here and this term will be divided, so e to the power 8 minus 1, and let's check whether or not we have matched with the result that we need to show. Yes, so 2 divided by e to the power 8 minus 1, and we have here proved. And next it says that find the mean of x. It is saying that we can see in the other question it said that find the mean of x. That means you have to find mean of that distribution, and it can be also divided by mu equals to ex. Now in this case your function is k, that means fx is k times e to the power 2x. So here we write integration of x, then k times e to the power 2x dx, and in the range of value of x from 0 to 4. Okay, so this can be written as k is outside, so k value we have already proved, k equals to 2 by e to the power 8 minus 1. So here we can write in place of k 2 divided by e to the power 8 minus 1, and then we have sine of integration 0 to 4 x e to the power 2x dx, and once we complete the integration of this function, we'll have the value of mean. So for our simplicity, what we can do, we can take for a while I equals to sine of integration x e to the power 2x dx, and this sort of term, it is in the form of product rule, that is also called the integration by part, where we suppose x as u and another term as dv by dx, and integration by part is given by, for example, given by integration of u times dv by dx equals to u times v minus sine of integration du by dx v dx, or you can write v times du by dx. You can write in either way, and this is called the formula for integration by part, that is available in your formula booklet as well. So if you apply this, so we can say in place of u there is x from x, and in place of dv by dx you have e to the power 2x equals to u times v. U is x, we don't know v, so v you have to find, since you can, if you compare these two, so dv by dx is e to the power 2x, and we are going to find what is v, so it is dv equals to e to the power 2x times dx, and now integrating both sides. So when you integrate both sides, so integration of dv will be v, and then integration of this function will be again 2x over 2, and at this time you don't need to write the constant term because we are dealing with the definite integral. So v is this, so in place of v you can write times, it is e to the power 2x over 2, and then we have term minus here, so we write the term minus, and then sine of integration du by dx means here we have in place of u we have x, so therefore du by dx will be equal to dx by dx, and that is equal to 1. So in place of du by dx you can write 1 times, and in place of v we have again here e to the power 2x by 2 dx. And now in the another step we can write x e to the power 2x by 2 minus 1, integration of this term will be again, this is 1 by 2, let's take it out, this is constant term, times e to the power. If you find again the integration of this, then it is going to be 2x divided by 2, and we don't need to write constant term here because we have to deal with the definite integral. So here we can write 2 divided by e to the power 8 minus 1, and then integration of this sort of thing. We have already seen that x times e to the power 2x terms integration is this. So we just copy it here. So inside the bracket, this is x e to the power 2x by 2 minus e to the power 2x by 4. So if you have term like this, and the range of values of x is 0 to 4, so we can write it is 0 to 4. Now let's put this value. This is 2 e to the power 8 minus 1. Now first we put value 4, so it is 4 times of e to the power 2x over 2 minus e to the power 2x means 2 times of 4, and here also e to the power 2 times of 4 divided by 4, and then we are left with plus 1. Finally we can write 7 times e to the power 8 plus 1 over 2 times e to the power minus 1, and this is the exact answer. If you want to have answer in some significant figure, you can use calculator also, or if it has been asked that you have to find the exact answer, you have to just leave it like this, or if you can find the answer up to some significant figure, you can use calculator and write the answer in whole number and in decimal form. Okay, let's talk about another example. So this example states that the continuous random variable x has PDF, that is probability density function, given by fx equal to k by x for x between 1 and 4 inclusive, and then 0 otherwise. And then you can see the graph of this function. So this is a reciprocal function. So if you use your knowledge in sketching the graph, your graph will be like this. And this function is defined statistically between 1 and 4, but mathematically there can be any value of x in the real number. It can be from positive infinity towards 0. Okay, in this way mathematically you can have any value of x between 0 and infinity, but statistically it says that this is valid for the value of x between 1 and 4 only, and 0 otherwise means even though there is in the part of this graph, you can have graph like this, and there are some more part below this point and ahead of x equal to 4, but statistically the probability is defined in this value of x. So that is defined in between 1 and 4 inclusive. And where k is a constant, it shows, then you have to show that k equal to 1 by 2 ln 2, and then you have to find expectation of x, then variance. After that, we have to show that median is 2, and also you have to show that the lower quartile is root 2, and you have to also find the upper quartile, that is q3. So let's start with this question number 1. So in question number 1, you have to first write total area equals to 1, since it is given that x is the random variable, since x is an RV, that is a random variable. Here in this case, definitely this is the continuous random variable. And total area means we write this way: x belongs to R, fx dx equals to 1, and so for x belongs to R, our range of values for x is from 1 to 4, and fx is k over x, then dx equals to 1. And after this, k is constant, so you take it outside of sign of integration, and then it is 1 to 4, 1 by x dx equals to 1. And we know that integration of this function 1 by x is ln x. So next step will be like this. So k times ln x for integration of 1 by x in the range of values of x from 1 to 4, and that is equal to 1. K equals to you have this is 1, and if you take this, transpose this to the other side, it's going to be divided here. This is ln4. We have to match up with what we have to show here. That means we have to work for that a little bit here. So it is ln4 means you can write ln in place of 4, you can write 2 squared, and then this is 1 divided by 2 squared. So this is like, you know that ln of a to the power n equals to, n will be here in front, so this is ln a, and same formula we apply for ln 2 square. So in that case we'll have 2 ln 2, and hence this is proved. Okay, in the next part of this example, in 2 say that you have to find ex equals to what? That means you have to find ex. Take the range of values of x from 1 to 4, and x is from this formula, and fx is we have k by x, and then we write here dx, so it's easy now. So these two are cancelled out, these two x's are cancelled out, and we already have the value of k obtained here, that is 1 by 2 ln 2. So we take this k value outside. So when you take this k value outside, it's going to be 1 by 2 ln 2 to the outside, and then we are left here with only value 1, and then dx, this is 1 2, and then if you like to express your answer up to 3 significant figure, you can just write 2.16 up to 3 sf, or otherwise stated you can also express your answer maybe up to 4 significant figure, or up to 3 significant figure only, 2 significant figure only. If you write up to 2 significant figure, it will be 2.2 only. Then we have already got up to find expectation of x. Now we have to find, in question number 3 we have to find vx, and you know that vx equals to what? So we know vx equals to expectation of x square minus mu square. Mu square means this expectation of x square. So first of all, as we have already obtained this value of mu here, then we work for ex square now. So we have expectation of x square equals to sine of integration in the given range of values of x, and this is, it is x square, so we write here x square fx dx. So that is expectation of x square equals to, our range of values for x is 1 to 4, you can see from here also it is 1 to 4. Then we have x square, our fx value is k over x, then dx. So you can write this k value over here also from here. So k value is, you can take it out first. So k value is 1 by 2 ln 2, and then sine of integration, you can, so x in denominator, and here 1x will be cancelled out from numerator and denominator. Then you are left with, this is x dx from 1 to 4, and then if you like you can write is 1 by ln 2 ln 2, or ln 4 also you can write, and then integration of this sort of thing is, here integration of x is here x square divided by 2 from 1 to 4. So now you can see here the variance is, so you can write variance of x as expectation of x square minus mu square equal to expectation of x square is here, so it is 15 over 2 ln 4, or you can also write ln 4 square when power goes to, when this coefficient goes to the power of 4, and minus mu square means that is 3, you can see here this is 3 divided by 2 ln 2, so this is 3 divided by 2 ln 2 and square. Now let's calculate. So it is 15 divided by ln of 16 minus, this is 3 3s are 9, and ln 2, so 2 ln 2 can also be written as ln 2 square, that is ln 4, so it is ln 4 square. Now take the calculator and calculate the answer. So it is, now you can see, 15 divided by 0.72702 and something like this. After there are a few more decimal place values, and if you would like to round off it to the three significant figure, then this is 0.727 up to 3 SF, and this is the answer. Okay, so we have now done up to dx. Now we have to show that median is. So we know how to find the median. So in order to find the median, we have to integrate the given value from the lower limit of x. So for example, say it is a and then to m, where m stands for median, and then it is fx dx equals to half, since median takes only 50% of the total values. So if you can have a look at this graph, so median position is somewhere here, exactly at the middle position m. So we have to integrate the given function from 1 to m. So here in this case, like if you go further from this step, it's going to be, so lower limit is 1, upper limit we have to find, this is median, and your fx is k by x dx equals to 1 by 2, and your value of k is 1 by 2 ln 2, and we'll take it out because it's constant. And then this step is going to be, so continue from here, this is 1 by ln of 2, it is ln of m minus ln 1 is 0, equals to 1 is left out here. So you know that ln of 1 is 0. Finally, we have ln m equals to, if you transpose this to the right, it's going to be ln of 2, and then from both sides you can eliminate ln and ln. Therefore, m equals to 2. That is, the median is 2, hence rho. And lastly, we have to also show that the lower quartile is root 2 and to find the upper quartile. So lower quartile, this is now 5, the question number 5, and it is said that to show lower quartile, q1 equals to root 2. So here, in the same way that we did while finding the median, so here we'll do the same thing. So it starts from 1 and ends to q1 fx dx equals to now 1 by 4, because if you talk about quartile value, first quartile it takes only 25% of the value, so it will be somewhere between 1 and m. So your q1 value will be somewhere in between 1 and m. So it is exactly at the middle of these two values. So it is q1 value here, and it takes the area about area of 25%. Okay. After this step, this is 1 to q1, and again we have fx equal to k, so k is 1 by 2 ln 2, and k by x, then we are left with here 1 by x dx, and that is equals to 1 by 4. So it is 1 by 2 ln 2, and then integration of 1 by x will be here ln of x, but at this time the range of values of x will be from 1 to q1, and that is 1 by 4. For example, if you are given that n ln a, then you can write by the law of logarithm a to the power n. If you apply the same rule over here, it's going to be ln 2 to the power half, that is 1 by 2. And now from both sides you can eliminate ln and ln. So therefore you are left with q1 equals to 2 to the power half, that means under root 2. Therefore the first quartile is root 2, and hence it is proved. Now in question number 5 itself, you have to also find the upper quartile. So another part of 5, we continue here, and we have to find q3 here. So q3 equals to what? So what you can do in this case, so we start from 1 and it goes up to 3. K value will be out here, and then it is 1 by x dx equals to 3 by 4. That means 3 by 4 is 75% of the values. So if you look at this graph, Q3 lies between M and 4. So Q3 is here exactly at the center of M and 4. So this is value Q3, and area up to Q3 if you see, so this area would be 75%, or 75% if you convert in fraction, this will be 3 over 4, ln 4. So this is the coefficient, and in another step you can put this to the power of 3 by 4 using the law of logarithm, and from both sides you can eliminate ln. So therefore you are left with here now q3 to the power q3 4 to the power 3 by 4, and then take a calculator, then find this value. So it is 4 to the power 3 divided by 4, and close this bracket, and it's going to be 2.8284, and a few more decimal places here. So if you would like to express your answer to three significant here, it is 2.83 up to 3 SL. And if you would like to express your answer in the exact form, what you can do here, so here Q3 equals to 4, you can say that yes, 4 means you can say this is 4 to the power 3 by 4, then it is 2 squared to the power 3 by 4, and then it is 2, and power gets multiplied, so 2 1 ja 2 2 ja here, so it is going to be 2 to the power 3 by 2, and 2 to the power 3 by 2 means how you can write here 2 to the power 1 by 2 times 2 to the power 1 by 2 times 2 to the power 1 by 2. So anyway you can express in terms of exact answer. So look at here, these are root, so this is 2 to the power 1 by 2, and if you consider these two together, then 1 by 2 plus 1 by 2 will be 1, so you're left with only 2. So your exact answer is 2. In place of root 2, in place of 2 to the power half, you can write under root 2. So this is the exact answer. Lastly, we have one more example, and this example states that the continuous random variable x has probability density function given by fx equal to k cos x, and the range of value of x is from 0 to pi by 2 and 0 otherwise, where k is a constant. Then you have to find the value of k, then ex, and then also the median of this probability density function. You have to find k. We have done a lot of work on it. So first of all, we write here total probability as 1 since x is an RV, that means the random variable, and total probability means for the given range of value of x, this is fx dx equal to 1. So here in this case values of x are between 0 and pi by 2, so we put here 0, and here in the upper limit this is pi by 2, and then in place of fx we have k cos x dx, and that is equal to 1, and k is constant term, so take it out, and if you integrate cos x, so integration of cos x is sin x, and the value of x's are from 0 to pi by 2, and that is equals to 1. So since you know that integration of cos x dx equals to 1, so you in order to solve this kind of problem, you should have sound knowledge of calculus. So here you can see you should have sound knowledge of integration, that is the integral calculus. And then k, put this upper limit and lower limit values for x, so it is going to be sine pi by 2 minus sine 0 equals to 1. So k times sine pi by 2 means it is sine 90 degree value is 1, so this is in the form of radian, and then sine 0 radian or 0 degree is 0, and it is 1, so therefore the value of k is 1. Now in the another part of this question, you have to find expectation of x. So you know that we know, so we are talking of second part of this question. So we know that expectation of x is for the given range of value of x. So x belongs to R, real number, and then x fx dx. So that is expectation of x equal to the sign of integration, and the range of value of x within which we have to integrate the function is 0 to pi by 2. So we write here 0 to pi by 2, then we have x, and then fx equal to k cos x dx. And we have already seen that value of k as 1. So this is 0 to pi by 2 x cos x dx, since we have found that k equals to 1. And now you can see that the function is in term of product of x and cos x. So here we require integration by part, and this formula states that integration of u times dv by dx and dx equal to uv minus v du by dx and dx, or du by dx times v. You can write that way also, and this sort of formula you can find in the Cambridge formula booklet also. So when you apply this formula, you can compare this function u as x and cos x as dv by dx. So therefore, first of all, we write here I. So I is equal to here x cos x dx, and then if you are applying this formula, so it is saying that u is already x here, so you can write x, and v means you have to find this way. So if you find v, then first of all it is dv by dx. If you compare these two, then it is dv by dx equal to cos x, and then it is dv equal to cos x dx. Now integrate both sides from here, then integration of dv will be v, and integration of cos x will be sin x. Alright, so in place of v we write here sin x, and then it is minus, again it is sin x times and du by dx. So here in this place, here in this case, in place of u we have x, so u equal to x. So therefore du by dx equal to dx by dx, that is equal to 1. So after that we are left with 1 here, then dx. And if you continue from here, it is x sin x minus, and the integration of sin x is minus cos x. So here, since integration of sin x equals to minus cos x, and plus constant term there will be, but as we are discrete integral, you don't need to write constant term because there is no use of this constant term. So therefore your expectation is now from this is the integration of x cos x, and we have that integration as x sin x minus minus plus, so it is x sin x, negative time negative is positive, so it is cos x, and then it is x sin x plus cos x, and then values are 0 to pi by 2. And after this step, first of all put pi by 2, so it is going to be pi by 2, and then sine pi by 2 plus cos pi by 2. After that, this is minus sine. Now this is turned to put 0 in place of x, so this is 0 times sine 0 plus it is cos 0. This way we can calculate. So it is pi by 2, and sine pi by 2 is, that is 90 degrees, so sine 90 degree is 1, and cos 90 degree, that is cos pi by 2 radian, is 0. It is minus, this term is 0, and negative times positive sign will be negative here, so it is minus cos 0 is 1. So you are left with pi by 2, so it is minus times plus is minus. Okay, so it is 0, this is 0 for here, and now minus 0 minus 1, so this is minus 1. and this is our answer. And lastly, you have to find the median of x. So you have to find the median of x. So this is third part of this question. So here it is asking you to find median. So median equal to, we know that in order to find median, median takes 50% of the values. So here median will be from any value a to m fx dx, and that is going to be equal to 50%, that is 0.5 you can put, or as you like you can put 1 by 2. So therefore we start with this value is fx. Fx is k times of cos x. So take the sign of integration from 0 to pi by 2 here. So it is 0 to, not pi by 2 now, it is 0 to m. So it is the middle value of 0 and pi by 2. And fx is k times cos x dx, and that is going to be equals to half. And we have already seen that in question number 1 of this, the first part of this question, that k equals to 1, then you are left with 0 to m, sine of integration 0 to m, this is cos x dx equals to half, and then it is cos x means integration of cos x is sine x, and this is 0 to m equals to half, since integration of cos x is sine x. And after this, you put these values. First of all, the upper limit, so it is sine m minus the lower limit of x is sine 0, and this is half, and then it is sine of m minus sine 0 is 0, so this is 1 by 2, so it is sine, looks like the same, so sine m is half now, so therefore m equals to sine inverse 1 by 2, and sine inverse 1 by 2 is 30 degree or pi by 6 radian. So therefore median in this case we have found is pi by 6, and this is the answer. I hope you'll be able to do all the problems from chapter 3, which is about the continuous random variable. So that is all for now, and thank you for your patience.